Hello. We are in the sessions for triangles. Previously, we had discussed on SAS, AAS rule of congruency. Had taken problems on SAS congruency. With some more theorems to be discussed, and then we move on to taking up questions on AAS and the theorems that I will be discussing here. The first one being, I draw a small figure here. I name this as ABC. The theorem says if two angles of a triangle, let it be as TRI, are equal, then sides opposite to them are equal. That means what? They say if in this triangle ABC, angle B is equal to angle C, then AB should also be equal to AC, because AB is opposite to the angle C and AC is opposite to angle B, which are equal. So given angle B is equal to angle C, and we have to prove AB equals AC. How do we do it? To do so, let us construct a bisector. It doesn't seem so, because bisector of an isosceles triangle actually will be a straight line as an altitude. This is not an accurate figure, so bear with it. Now what we do is name this as D and try to prove the congruency of the triangle ABD and triangle ACD. How will this be done? It will be like angle in triangle ABD and triangle ACD, angle ABD will be equal to angle ACD. AD will be common, and one more is angle BAD will be equal to angle CAD. These two angles will be equal because we had drawn AD to be the bisector of the angle BAC. Thereby, by this to A. Oh, I'm taking up ASA congruency. This is angle, this is angle, this is side. Okay, so it is AAS congruency. We prove the congruency of these two triangles. Thereby, CPCT we can say AB is equal to AC. One more theorem I can write here. I move on to another screen. I draw the figure again. It says if the altitude from one vertex of a triangle bisects the opposite side, then the triangle is isosceles. That means if I am dropping an altitude from this point to the other side, I name this as BC, and this AD is bisecting BC, then this triangle is isosceles. To prove the triangle to be isosceles, we can either we prove angle this side AB will be equal to AC, then this triangle becomes an isosceles triangle. To do so, again we take triangle ABD and triangle ACD. We already know this angle BD is equal to DC, As because we have drawn this to be the altitude, so angle ADC will be equal to angle ADB. Oh, I should be writing ADB because I had taken this as BD, and this should be C here. And the third part is AD is common. Either you write AD common or it is AD equal to AD. So thereby SAS congruency, we can prove ABD congruent to ACD by CPCT. You can say AB is equal to AC, thereby making ABC triangle an isosceles one. We move on to another theorem. This is just the converse of what we discussed just before. This is ABC. It says in an isosceles triangle, altitude from the vertex bisects the base. This is an isosceles triangle. That means AB will be equal to AC. I'm taking those two sides equal in the isosceles triangle. I drop a perpendicular from the vertex. I drop a perpendicular from the vertex to the side BC, and it says if this is the altitude from the vertex, then this, if suppose this is D, then BD should be equal to DC. That means given is AB equals AC, we have to prove BD equals, only when BD is equal CD, then only it is bisected, na? So BD equals DC. Now again we prove the congruency of triangle ABD and ACD. So proving the congruency, you say AD is again common, AB is equal to AC, right? Though we need it angle, then we have to prove, no, I don't need this, otherwise I'm taking this aside. Okay, angle ADB is given to be equal to angle ADC, as it is an altitude and it makes 90 degree. I have taken up a side angle, so I take up this angle. As because it's an isosceles triangle, it is ABD will be equal to ACD, or you simply write angle B is equal to angle C, thereby proving the congruency by AAS rule, and again by CPCT you can say BD is equal to CD. Let's take up few questions based on these theorems. I write a question here. Triangle ABC is an isosceles triangle with AB equals AC. Side BA is produced to D such that AB is equal to AD. We have to prove that angle BCD is a right angle. So let's draw an isosceles triangle with AB equals AC. Hope it looks AB equals AC. Now let us produce BA. It has produced BA such that AB is equal to AD. Oh, I should have drawn a little smaller one. I would have better drawn a. I'll draw a little smaller triangle, because then let me extend it, as because it says they will be equal. So this is how it would look like. This is A, B, C, where it says AB equals AC. Even D, this is the point D, which is equal to AB. Prove angle BCD. Oh, I have to join this as well. So I have to prove angle BCD to be 90 degrees. How do we do so? We have to take up BCD to be 90 degrees. Let's see. In triangle ABC, AB is equal to AC, right? Therefore, angle ABC is also equal to angle ACB. These two angle opposite to equal sides will be equal. Also says AB is equal to AD. As because, see, AB was equal to AC, AB is also equal to AD, thereby making AD equal to AC as well. If AC is equal to AD, thereby making these two angles equal, this is again angles opposite to equal sides, so you write angle ACD also equal to angle ADC. This was 1 we got, this is 2 we get. Angle ABC plus angle ADC plus, so now this can be written differently. I can write it as ADC is also equal to angle ACD. Now I make this a 2A. So if I add this equation 1 plus equation 2A, it would make angle ABC, because I need ACD to be added to ACD to be added to ACB. Therefore, I write it like that. So ABC plus angle ADC will be equal to angle ACB plus angle ACD. So this becomes the whole of angle BCD. So I write BCD is equal to angle ABC plus angle ADC. Now if I add BCD, ABC is also there, ADC there. Now I add BCD to both the sides. If I add BC to both the sides, it would be like ABC plus ADC plus BCD. Even if I add another BCD on RHS. So this, if you see, is ABC, ADC and BCD. This is sum of the angles of a triangle makes 180 degree, and this side it becomes twice of angle BCD. So angle BCD becomes 180 by 2, that is 90. This is what we were supposed to prove. Angle BCD is a a right angle. Hope you followed it well. Thank you.